All right, so we're going to look at log laws today. However, before we start talking about log laws, I'd like you to try these two diploma questions, which covers concepts that we learned last lesson, and see how you do with them. So press pause on this video, try the questions, and then press play, because right now I'm going to go through the answers. So to start with, numeric response 3, we know that log with a base of a and argument of 8 equals 3. And we also know log with a base of 4 and argument of b equals 3 over 2. Then it asks for the value of log ab plus log ba. So the first step is we need to figure out what a and b equals. We need to find the numerical value for those two variables. I might be able to figure it out, but when you're working with logarithms and exponents, you need to be able to work back and forth. So what we're going to do here is we're going to convert this log into exponential form. So our base is a, our exponent is 3, and it all equals our argument, which is 8. Now, just by looking at this, you should probably be able to tell that it equals 2. If you didn't know that just by looking at it, you could also cube root both sides of the equation in order to isolate that a variable. Now over here, we're once again going to convert to exponential form. So my base is 4, my exponent is 3 over 2, and it all equals my argument, which is b. So this one, just type in your calculator, and you should end up getting a b value of 8. So now that I know my a value and my b value, I'm simply going to substitute them in to this logarithmic expression. So log a, which is 2, b, which is 8, plus log b, which is 8, and a, which is 2. And I'll just go ahead and type that in my calculator. So try typing that in. You should get 3.33 as your answer. All right, let's try the next one. So it says a logarithmic form of the equation 4a to the third equals b, where a is greater than 1. So when we're converting, there's a few different ways we can go about this. For me, I look at the answers and I know I'm trying to convert to logarithmic form. I would start off by isolating that a value. So remember, before we convert to logarithmic form, our exponent needs to be isolated. So that means I'm going to need to divide this 4 to the other side of the equation. Now my a to the third is isolated. After it's isolated, I can just convert to logarithmic form. So now I have a base of a, an argument of b over 4, and it all equals that exponent is of 3. So I know that my correct answer is b. We've talked a lot about in this course, especially with these diploma questions, it's so important to find a different method to verify. So with this particular question, I would probably substitute a number in for a. So say I pick 3 or 2, type that in my calculator to get my b value, and then make sure that once I substitute those two numbers in, that b actually correctly works out to equal 3. Okay, so now we're moving into the new part of the lesson, laws of logarithms. So log laws. It's almost like opposite to exponent laws. This is on your formula sheet. You do not need to memorize it. So first of all, when we have a log with a base, okay, so pretty much if you have a log with the same base and you're adding the two logarithms, you can multiply the arguments. So here I have a log bm, a log bn. That's the same as if I were to multiply those two arguments. The same holds true with division. So if I subtract two logarithms and they have to have the same base, then I can divide the two arguments. And lastly, this one's pretty important. If you have an argument that's raised to an exponent, you can actually move that exponent as the coefficient on your logarithm. However, one thing you need to watch for that they try to trick you a lot is notice how that exponent is only applied to the argument. So in other words, in this case, I can move that forward. So these two expressions are equivalent. However, this is not the same as this. There is actually no log law if you were to raise the entire logarithm, so that's not the same thing. So this only holds true if the exponent is only applied to the argument, not the entire logarithmic function. Okay, so let's go ahead and simplify. All right, so here there is no base, so we assume they're both common logarithms, which means they have a base of 10, but we don't need to write that there. So we can go ahead and divide those two arguments. 50 divided by 25 is 2. Next one, same base. We're going to multiply these two arguments. 5 times 12 is 60. And once again, if I ever wanted to double check, especially when we work with some more complicated problems, if I type this in my calculator and my simplified expression in my calculator, they should both give me the same decimal value if I did it correctly. Okay, and lastly, we are going to move this coefficient of 3 onto the exponent of my base of 4. 4 to the power, or 4 to the exponent of 3 is 64. All right. Now we get into a little more complicated of a problem. So it says simplify the following expression as a single logarithm. So always go back to your BEDMAS laws. So as soon as I see those brackets, I'm going to start there. So I have log x 10 plus log x 75 minus, okay, we are adding two logarithms with the same base, which means we multiply the arguments. 2 times 3 is 6. You could also distribute that negative as well, and you should end up with the same answer at the end. However, I chose to simplify what was in the brackets first. Okay, so now when we're working with log laws, a general rule of thumb, if it's positive, the argument goes in the numerator. Positive, numerator. If your logarithm is negative, the argument goes to the denominator. Okay, so now I'm just going to go ahead and type this in my calculator. So log x, bracket 10 times 75 divided by 6 should give me 125. So my simplified expression is log x 125. Okay, and then if you evaluate and you just substitute a 5 in for that x, type that in your calculator, you should be able to evaluate to an answer of 3. All right, we're going to just practice simplifying a little more with our log laws. Whenever I'm simplifying, and again, I would press pause, try it by yourself, and then press play. Whenever I'm simplifying, I usually start by moving the coefficients as exponents on the arguments. So I would start here, and because I'm subtracting two logarithms with the same base, I will go ahead and divide those arguments. Okay, so next question, I'm going to start by moving all my coefficients as exponents on the argument. Okay. And now, again, anything that's positive goes in the numerator. Anything that's negative goes in the denominator. So this is a positive log z squared, so it's also going to go in the numerator. Sometimes I have kids who try to attach this, but that's not true. You always work from left to right. Okay, another thing you should be familiar with is your answer could be written as a fractional exponent. It also could be written as a radical. So you should be able to recognize that both of these are the same answer. Okay, this one always tricks kids. So right now I can't use log laws. Remember, you can only use log laws if you have two logarithms with the same base. This 2, that is not a log. So I can't just go ahead and multiply it. So what I can do is I can turn this into a log, but in order to use log laws, it would need to have a base of 4. So I need a log 4 with an argument, and I need this whole expression to equal 2 so that I can substitute it in. So now you can kind of guess and check, or you can convert to exponential form to figure out that argument. So 4 squared is 16. So log 416 is equal to 2. So because it's equivalent to 2, I can just go ahead and substitute that in for the 2. And now from here, I'll keep going through the question. So now I can use log laws because I have the same base. So when we add two logs with the same base, we multiply the arguments. So I end up with log 4, 48. All right, we'll keep moving here. So this just increases in complexity a bit. So it says write the expression as a single logarithm. So again, I'm going to start the same way and move all of my coefficients to the exponent of the argument. Notice how the second argument, that 2x minus 3 is in brackets. That means that entire expression is part of your argument. So now they both have similar bases. They're both common logarithms, meaning they have a base of 10. We are adding two logarithms with the same base, so we will use log laws and multiply the two arguments. So I have x to the third multiplied by 2x minus 3. And then from here, I'll just distribute that x to the third to that expression, and I end up with 2x to the fourth minus 3x to the third. When you're working with these types of problems, it is very important to remain consistent with your notation. So make sure that you still have the brackets. If the bracket wasn't there, we would assume that just the first term was part of the argument, but we want the entire expression to be part of the argument. So you need to make sure that you're very precise about that notation. Okay, next question. So it says we're subtracting two logs with the same base. So we're going to divide these two arguments. Okay, and then I would probably try to factor them just to see if anything cancels out. So let's go ahead and factor 2x squared plus x minus 3. I'm going to use decomposition. You can use any method of your choice. Two numbers that multiply to give me -6 and add to give me +1 are, of course, +3 and -2. So I'm going to replace that +1 with -2 and +3. Now I'll factor each half. I'm running out of room, so I'm going to write on the left here. 2x bracket x minus 1 plus 3 bracket x minus 1. Okay, so now I'm going to just replace that 2x squared plus x minus 3 with the factored form of that quadratic. Okay, and then hopefully you would have noticed that the denominator is just a difference of squares, so that's super easy to factor. So now I can go ahead and cross out the common factors with the numerator and the denominator, which is x minus 1, and I'm left with an expression of just 2x plus 3 over x plus 1. Okay, so evaluate each expression. We'll just finish really quickly here. So honestly, you can just type this in your calculator. I would try using log laws just to practice. So if I use log laws, that means that I'm going to bring that 3 as an exponent on my argument. And I will bring the 4 as an exponent on the argument of the third term here. So then I end up with log 9(2). 6 to the exponent of 3 is, and you can actually type that in your calculator. I think it's 216, but let's double check. 216, woo, I was right. Minus 2 to the power of exponent of 4 is 16. So now we have a positive argument of 2, a positive argument of 216, and a negative in front of that argument of 16. So this is what it'll look like. Okay, if you type that in your calculator and work it all out, you should end up with an answer of log 927, which evaluates to 3 over 2. Okay, and we're going to look at one more diploma style question here. So this one is actually a tricky one for kids. Okay, so this time we're given log 2x equals a, and we want to rewrite this as an expression with a. So far we've used log laws to bring an expression together. Now we're going to use log laws to break this argument apart. So it's like I'm working backwards here. So I'm going to break this argument apart. So I'm breaking those two arguments apart, which means I'm going to add the two logarithms. And of course they need to have the same base. Okay, log 216, from here I can evaluate that just equals 4, and you can type that in your calculator. I'll use log laws and bring the exponent forward as a coefficient. And now I've gotten to the point where I have log 2x. That's my goal, is because now that I have that exact same expression, I can substitute an a for it. So then I end up with just 4 plus 2a as my final answer. So that's a really important one for you to understand. With log laws, not only can you use them to bring expressions together, but you can also use log laws to break expressions up. Here's some questions I highly suggest that you practice.